Hello, welcome again. Uh, Hopefully you remember that in the last video we have seen De Morgan's law with two variables, isn't it? And I told that in the next video I will talk about De Morgan's law with three variables. So today we'll do that. See, it's De Morgan's law with three variables. A plus B plus C whole bar is equal to A bar dot B bar dot C bar. We will see how we can prove that. Okay. See, first we need to write A as an input, then B, then C. Then we'll write A plus B plus C, and finally A plus B plus C whole bar. That means this is my left hand side. See, I have follows the sequence. A plus B plus C, this is my input. So directly we will not write A plus B plus C whole bar, then there will be a confusion. So I have created A plus B plus C first, then A plus B plus C whole bar. Again, like that we will not write A bar dot B bar dot C bar, rather we will find out the value of A bar, then B bar, then C bar. Finally we will find out the value of A bar dot B bar dot C bar. And then we'll match whether the value of this and this is equal or not. If it is equal, then it proves. Now, what are the value that we'll write here? That is very important. Okay. In my last video, when it was with two variables that you have seen, there was a formula 2 to the power 2 minus 1 is equal to 3. So the values come up to 3. In case of how many variables? In case of two variables. If it is three variables, so power comes here, 2 to the power 3 minus 1 is equal to 7. So the value will start from 0 and it will go up to 7. Correct. It will go up to 7. So how we can start with 0 and up to 7? See, 0, 0, 0 is equal to 0. Then we need to write out binary 1. 0, 0, 1. It is 1. Then we'll write down 2. 0, 1, 0 is 2. Then 0, 1, 1 is 3. 1, 0, 0 is 4. 1, 0, 1 is 5. 1, 1, 0 is 6. And 1, 1, 1 is 7. So it goes up to, it starts from 0 and up to 7. Now, let's say you forgot, okay? In between you forgot what is the binary value of 6 or binary value of 5. Then how you can do that? You know, 8, 4, 2, 1 method, okay? Let's say I would like to find out the binary value of 5 with this. So 4 plus 1 is equal to 5. So 1 and 1 here, you put 0. So it became 5, okay? Let's say you would like to find out 6. So 4 plus 2, 6. Okay. For this, I'll put 0. So 1, 1, 0 it became 6. 1, 0, 1 became 5. So this is one of the easy way to remember. One more trick that I would like to tell you for only for this. This one, like for up to 7. How we can prove it? We'll tell you how we can write down the values up to 7. See, here if you see very carefully A, B and C, you can see 4 zeros, okay, then 4 ones. For the next one, instead of 4 0, 2 0, 2 1, this is how it goes 1. And for C, instead of 2, now it is 1 0, 1, 0, 1, like this. You can remember in that way as well, only for De Morgan's law with three variables if you want to prove. Now we'll see what is the value of A plus B plus C. What does it indicate? Definitely logical OR. And in logical OR, what we have seen? If all the inputs are 0, then only the result is 0, otherwise 1. So all the input here, all the three inputs are 0, so result is 0. Now somewhere 1 is there, so it is all of them will be 1. Done. For about this, we'll not look over here, we'll compare with this, because a plus b plus c whole bar. So which gate, which logical gate does it indicate? It's NAND. Okay, no, sorry, it's not, that you have seen. Okay, a is a bar, that means if you pass 0, it will be 1. So same thing here as well, a plus b plus c, and it is whole bar. So this 0 will be 1, remaining all of them will be 0. Done. Now we'll think about this one. This one is a bar. So compare with this. How many 0? 4 zeros. So 4 1s will come. Okay. Now think about B. Just compare this with this. Okay. So 2 0 2 1 like this. So 2 0 is 2 1. 2 0. Again 1. 0 0. Now we'll compare this C bar with C. 0 1 0 1. So 1 0 1 0 1 0 and again 1 0. Now forget about this part. Come here. This one indicates which gate? Logical AND. In case of logical AND, what do you know? If all the inputs are positive, that means 1, the result is positive, otherwise negative. Here you can see all the inputs are positive, positive. Somewhere negative is there. That means 0 is there. So all of them will be 0. Now, what we need to prove? A plus B plus C whole bar is equal to A bar dot B bar dot C bar. That means we will compare this with this. See the values. 1, 1, remaining all of them 0. Here also 0. What does it mean? Our De Morgan's law with 3 variable is proved. It's very simple. If you only see this, you may get confused where to write 0, where to write 1. But if you follow a sequence, it's very simple, I find. Hopefully you guys have understood this one. So De Morgan's law with 2 variables and 3 variables is done. Here, after this, today I'll just start Boolean algebra. Okay? And 1 or 2 simple proofs, expression will prove. Then in the next video again, we'll go further. In Boolean algebra, again, okay, I'm not making it very long. Simple things I'll tell you today about Boolean algebra. There are some formulas in Boolean algebra, like a plus 0 is equal to a plus 1 is equal to 1, a plus a is equal to a, and a dot a is equal to, this is also a. So, first one, like a plus a bar, like a plus a bar is equal to 1 and a dot a bar is equal to 0. We need to remember this. A plus 0, very simple, it's a. But see this one, a plus 1 is equal to 1. We'll have to remember it, exceptional. A plus a, it's not 2a. A plus a is again a. A dot a is not a square, a. A plus a bar is equal to 1. A dot a bar is equal to 0. Now from here, 1 or 2 will see, like how a plus a bar, these two will see how a plus a bar is equal to 1. Again I am writing here a plus a bar is equal to 1 and a dot a bar is equal to 0. Let's say I am giving this one 1, this is 2. We will see how first one is 1. A plus a bar is equal to, assume a is equal to 1. Assume, I am assuming a is equal to 1. So if a is equal to 1, what will be the value of a bar? just opposite that we have seen already in De Morgan's law. So if it is 1, it will be 0. So 1 proved. Okay. Now again, if it is a into a bar, assuming again the value of a is equal to 1, like before, dot, then what is the value of a bar? Definitely 0. So 1 into 0 is 0. Okay, understood? Finally, for today, I'll finish with one more thing. Let's say a plus bc is equal to a plus b into a plus c. This one we'll have to prove that. Okay, we'll have to prove it. Left hand side, right hand side. So I'll take the right hand side. A plus b, okay, to a plus c. Let's see whether this one I am getting after simplification I am getting this one or not. So in between this, what is there? Dot, that means multiplication. And all of us, I think all of you know multiplication very easily. You can do it very easily. With a, we'll have to multiply this 2. So a dot a plus a dot c plus, again this one, ba. Instead of ba, I am writing ab plus bc. Okay. Now, what is the value of a dot a? I just have rubbed it. It was written a dot a is equal to not a square, a. So a plus ac plus ab plus bc. Now this. Between these two, what I can take common? Definitely a. So I have taken. So it is 1 plus c, ab plus bc. What is the value of 1 plus c? We have seen 1 plus a is equal to 1. So 1 plus c is equal to definitely 1. So it became a plus ab plus bc. Again from this, what we can take? A as common we can take. Then it became 1 plus b is left. Okay, plus bc. Now here, what is the value of 1 plus b? Definitely 1 plus b is equal to 1. Again the same formula. So we got this one is equal to a plus bc. Now, what is this? A plus bc. So this is equal to RHS. Okay? LHS. This one is our RHS and this became LHS. Proved. Only thing is, we will have to remember the formula. Okay? That's it. Then you can do any of the simplification very easily. Hopefully all of you have understood. Thank you very much. If you like it, just click on like. You can subscribe as well. You can press on bell button for the next notification of the next videos. Thank you very much. Okay?